Hi, this is Stephen Marrone here talking about my senior project, Smart Safeguard, under advisor Dr. Bridget Benson at Cal Poly San Luis Obispo. So the major motivation for my project came from this graph right here, which shows of the car crashes in the United States with a known time of death, the majority of the deaths occurred in the first 9 minutes after the crash. So my thought was, if the emergency first responders could get there earlier before the 9-minute mark occurred, then some of those deaths could be prevented. So I set out to create a system that would detect a car crash and then notify the paramedics or 911, the emergency first responders, of the car crash and the location the car crash occurred. So the system has a microcontroller to control everything and run the program, has a Bluetooth module to connect with the user's phone, and has accelerometer to detect if a car crash occurred by detecting a large change in acceleration, and it has a GPS module to get the location of the car crash. It also has some voltage regulators to assist each one of those modules. So I also analyzed two main competitors, and based on those I found some shortcomings that they might have to the market and try to solve those with Smart Safeguard. So the first one and the most well known is OnStar. So OnStar is technology that's built into the GM cars. So that's one of the main downsides of it, is it has to be built into the car that you buy, which means it has to be a GM car. Another downside is the price. It costs $20 a month for a similar service that Smart Safeguard will provide. And the response time is greater than a minute because you have to go through their OnStar representatives before you can connect to emergency services. So those are the main problems with OnStar that I hope to solve with Smart Safeguard. Another interesting competitor is SOS Smart, a app that works on any iOS or Android phone, so you need a smartphone, and it's compatible with any car. The price is free. Those are all good things. The response time is probably greater than 2 minutes because the way it works is when it uses your phone's sensors to detect a car crash, it sends a text or a message to the people you tell it to on your contact list, and those people have to then go and call you to see if you're okay or contact 911 for you. So it can take a while for it to actually work correctly. And another bad part about it is, since every phone has a different accelerometer or different sensors, it can't necessarily account for every single phone and the changes of each of those, so it's not exactly the most accurate at detecting crashes. So enter Smart Safeguard, my senior project. It notifies the first responders 15 seconds after a crash. It costs $80, and it works with any car in any Android phone. So here's the bill of materials, and this was for my final draft of it, but again, if I was mass producing this, it would be a lot cheaper because I could buy these parts in bulk and save some money there, but it totaled up to $68. And here's the schematic. In the center of it, we have the ATmega 328P, which is also what's in the Arduino. We have a 16 megahertz crystal. On the bottom right, we have the accelerometer, which measures X, Y, and Z acceleration and feeds out a voltage proportional to that into the analog pins of the Arduino. We have a GPS and Bluetooth breakout boards there. We've got a voltage regulator and some LEDs also, along with a buzzer and a button. And then here's the layout for that. I did a 1-layer board due to the limitations of the milling machine that I was using, so it'll fit on 1 layer.
Okay, so here we are in San Luis Obispo. This is Stephen Marrone for my final video presentation of Smart Safeguard, my senior project for Dr. Bridget Benson. So we're in a car right now, just on a side street parked for the demo. So right now we have the project with a green LED so that you can know when it's connected to GPS, a red LED and a buzzer so that you can know when a crash is detected, and a button so that you can tell the system that you're okay after a crash. And then we have the 12-volt input, goes through there, through a wire and straight into the car right there for the 12-volt like cigarette lighter. So now I'm going to turn this guy on, which just flip this switch, that LED turns on, And then we are going to wait for the green LED to turn on and connect to GPS. In the meantime though, I'm going to use my phone to connect to the Bluetooth module. So we need this app called Arduino SMS. So we do that, we click, oh sorry, let me close this. So bam, go to Arduino SMS. That's not it. There it is, paired devices, HC05. That's the name of the Bluetooth module in the Arduino, or in the Smart Safeguard. So right there, it's connected now. And we're still waiting for the GPS module to acquire a lock. Sometimes it can take up to 2 minutes. Just depends on where the satellites are in relation to the GPS module currently. So. Oh, there we go. So GPS lock has been acquired. So now I'm going to shake the module to simulate a crash, since obviously don't want to crash the car. So okay, so there we go. So the red light and the buzzer are both going off. So I'm going to push the button to show that that works right now. So as you can see, push the button, the LED and the buzzer are both turned off. So the system's just going back to normal, back to monitoring for car crashes. So I'm going to shake it again. Boom. So now I'm gonna let it go through the 15 seconds and see what the text looks like on my phone. Okay, so 15 seconds have gone by, so we should look on my phone right there, go to the app, and it says, help, there's been a car crash at location, latitude, longitude, and it has the numbers. So if you go and plug those into Google Maps, you should be able to see that we are right at the intersection of Patricia and Cerro Romaldo. And that's my demonstration. Thank you very much. Go. Hi, it's Stephen Marrone at the Senior Project Expo. Here to show off my project, Smart Safeguard. So we've got it all in this box here, and I'm going to put it on this RC car and then crash it, and then you'll be able to see the box told my phone, which is right here, to text 911, or basically myself for testing purposes, that there's been a car crash, and it'll have a location. So put it on there, and then grab my phone with me. Then I'm going to crash the car. Ready? There we go. And then as you can see, it's beeping. So I'm going to let it go for 15 seconds. And then after 15 seconds, I should get a new text from myself. And bam, right there. And as you can see, it says there's been a car crash at the location. Thank you very much.